All right, let's talk about Node.js clustering. I know, it sounds kind of heavy, but it's absolutely crucial if you want to scale your apps. And don't worry, we're not going to drown you in boring documentation. Instead, I've got a simple story for you, a story that I promise will make this whole thing click. So let's dive in.
So, to really get a grip on how clustering works, and more importantly, why you should care, we're going to use a simple analogy. Just imagine a big city, tons of hungry customers, and one very, very busy delivery boy. All right, section 1, the lone delivery boy. Let's meet our hero. Okay, so imagine this huge, bustling city. This city, that's your server. And inside this whole sprawling metropolis, there is just one delivery boy. That's right, one guy handling every single order. Now, this delivery boy, he's a rock star. He's super fast, super smart. But, and this is a big but, he has one major limitation. He can only deliver one order at a time. He has to pick it up, deliver it, and come all the way back before he can even think about the next one. And that right there is exactly how single-threaded Node.js works. You see, by default, your Node app runs on just one single thread. It only uses one of your machine's CPU cores, even if you have a beast of a machine with tons of them. It's literally our lone delivery boy doing all the work by himself.
Okay, section 2, a city overwhelmed. Now this is where things start to go wrong.
So what happens when the city starts to grow? I mean, really grow. Business is booming, and suddenly everyone is placing an order. What do you think happens?
Well, it's pretty much a disaster, right? The complaints start pouring in. Why is he taking so long? Where's my food? And in our world, that translates to, why does the server lag so much under load? You got hundreds of new orders, new requests, all coming in at once. And our poor delivery boy, he's just completely swamped. And here's the crazy part. Technically speaking, your machine, your server, it might have 4, 8, or even more CPU cores just sitting there, ready to work. But your Node app, it's only using one of them. The rest are literally doing nothing, just chilling, while that one single core is sweating and trying to handle everything. It's a huge waste of power.
But okay, don't panic. There's a solution. This brings us to section 3, the mayor's smart plan. So, the mayor sees all this chaos, right? And he has this brilliant idea. He looks around and says, wait a second. Why should this one poor kid struggle all by himself? I've got 8 different roads in this city, 8 CPU cores. Let's assign one delivery boy to each road. It's simple, but it's a game changer. And just like that, the mayor rolls out his new plan. He's not just hiring a bunch of people randomly. No, he's smart about it. He assigns delivery boy number 1 to CPU core 1. Delivery boy 2 gets core 2, delivery boy 3 gets core 3, and so on, for every single available core.
And that, my friends, is Node.js clustering. It's that simple. The mayor is the master process, and the delivery boys are the worker processes, each running on its own CPU core.
So now that you get the basic idea, let's dive a little deeper. Section 4, how clustering actually works.
The advantages here are huge. First off, the load gets shared evenly among all the delivery boys. No one person gets buried in work. But here's the really cool part. What if one delivery boy, gets a flat tire or just collapses from exhaustion? Well, the mayor just hires a replacement instantly. The rest of the team keeps working. The whole service doesn't crash. Plus, orders are now being handled at the same time, in parallel, which means no more insane waiting lines.
So let's just map this out clearly. The city near our story, that's your server, your operating system. The mayor, that's the cluster master process. Each delivery boy is a worker process. The roads they use are the CPU cores. And those new deliveries are your incoming HTTP requests. And the most important part, the act of hiring a new worker, that's the cluster.fork function in your code. It's a perfect match.
Okay, let's picture this. Before clustering, what you have is a bunch of CPU cores, but only one is actually doing any work. All your user requests are stuck in a massive traffic jam, all waiting to be handled by that one single Node.js process. It's incredibly inefficient. But now look at the after picture. You've got the master process, our mayor, acting like an expert traffic controller. He's distributing all the incoming requests to this whole team of worker processes. Each one has its own CPU core, and they're all working at the same time. The bottleneck, it's just gone. This is what true parallelism looks like. So what's the bottom line here? What do you get out of all this? Well, you're finally using all the CPU cores on your machine. That means you get a massive boost in performance. Your app is way more resilient and fault-tolerant. And scaling up is super easy. You just add more workers. It's a total win.
All right, we've gone through the whole story. Let's wrap it up with our final section and the most important thing to remember. So look, if you take away just one thing from all this, let it be this. Node.js by itself is single-threaded. But the clustering module lets you get around that. It creates multiple Node.js processes so that every single CPU core can run its own event loop. And that gives you true parallel processing, much higher throughput, and way better fault tolerance. Clustering is, without a doubt, a super powerful solution for CPU-heavy tasks. But, every solution comes with new questions. For example, how do you handle state when you have all of these different workers that can't directly talk to each other? So the question I'll leave you with is, what new challenges might clustering introduce for your application? Something to think about. Hey, if this story helped things click for you, do me a favor and hit that like button, subscribe, and turn on notifications so you don't miss the next one. Catch you later.